Welcome to part 3 of my RCA sound cartridge series. In the first episode, we had no sound from the player, so we decided to replace all the wax paper caps and electrolytic filter capacitor. In the second episode, I showed my new method to replace multi-section filter capacitors and the unique way I find the foil side of capacitors. I replaced the wax paper caps, tested and replaced faulty resistors, removed corrosion from the RCA jacks, replaced the selenium rectifiers, and showed you how to calculate values for dropping resistors. Finally, I removed the fossilized remains of the old belt and installed a new one. And all that added up to finally getting some sound out of our player. Noisy, squeaky sound, that is. And our rewind wasn't working. So, in this episode, we'll fix the squeak and rewind and listen to excerpts from a cartridge where someone way back recorded both the JFK funeral and Nixon resignation. And definitely stay tuned to the end to see if you can figure out my colossal mistake attempting to tame the buzz from the outboard amp. So that's the squeaky sound I was telling you about. To fix this, I first adjusted the take-up clutch. The clutch is comprised of a felt disc and spring which drives the take-up hub. The felt disc and spring are engaged by the take-up pulley, but only to a certain degree. If the take-up hub encounters resistance, the felt disc will spin free, effectively disengaging the take-up pulley. This serves to both protect tape cartridges and the belts and motor. Now, the degree to which the felt disc spins or grabs is controlled by the tension applied to the clutch assembly spring. If it's too loose, the take-up hub won't spin at all. And if it's too tight, not only could the cartridge, motor, or belts be damaged, the fast-moving belt can also slip along the take-up pulley, causing friction and squeaks. By adjusting the spring tension, I was able to find a good balance, which allowed the take-up hub to spin properly without any belt slippage. This greatly improved the squeaking, but I was still having some issues as the pinch roller was badly worn. I've collected a few of these players, so to fix this, I took the pinch roller from another player, which remarkably is in almost new condition. Why cannibalize the other player? Well, it's a mono unit, and I've elected to give priority to my stereo players like this one. Here you can see I've installed the replacement pinch roller and the badly worn one, which I removed. You can also see what great shape the replacement roller is in, especially after an application of pinch roller cleaner and rejuvenator. I neglected to record video of the malfunctioning rewind, but I can tell you that figuring it out drove me a little batty. No matter what I seemed to adjust, I just couldn't get the player to lock into the rewind position. I even got so frustrated that I decided to check the manual. Such shame. I'm glad I did though, as right there in black and white was the solution to my problem. Rewind busted? Your rewind idler link is bent, dummy. The complicated fix? Straighten it. That should fix it. I have the rewind now working, and I think I fixed that issue with the squeakiness. Let's give this a try. First, I'll demonstrate the rewind. And as you can see, when you rewind, the heads stay in place. They don't retract, so as you're rewinding, you can actually hear the sound on the tape. This, unfortunately, causes a little extra wear on the tape, but it does make trying to find the place on the tape you're looking for a little bit easier. Let's try play mode now.
Is a peace abroad and prosperity without inflation at home. Therefore, I shall resign the presidency effective at noon tomorrow.
What you're hearing is the Nixon resignation. This is a mono tape, so on this side of the cassette, there are two mono tracks. On one, someone has recorded the Nixon resignation, and on the other, the JFK funeral. So this is a very interesting cassette indeed. This switch selects between mono and stereo. This would be the stereo mode, and this is mono. The left-hand position is for when listening to stereo tracks, or for listening to one of the mono tracks. By switching to the right position, in mono mode, you would switch to the other track. With a mono tape and this switch in the stereo position, you would hear both mono tracks at the same time. Let's keep this in mono mode and play the cassette, and I'll switch between the two mono tracks. Again, one is the Nixon resignation and the other the Kennedy funeral. Here we go.
Toward the engine.
Vice President Ford, I know, as I told the nation when I nominated him for that office 10 months ago, to begin healing the wounds of this nation, to put the bitterness, divisions of the recent past behind us. That lie at the heart of our strength and unity as a great and as a free people. By taking this action,
I'm not sure if somebody made these recordings from the television or radio, but if they were recorded live, say from the radio, these two recordings would have been made about a decade apart. Now in the background, you may hear a bit of noise, and that's coming from our solid-state outboard amp and speaker. There's an electrolytic in here that's clearly leaky. Let's fix that now. Let me put the speaker right up to the microphone so you can hear the hum a little better. Let's take a closer look now at our outboard speaker and amplifier. You can see by these hinges and this latch that it serves as the outer cover for the player. Looks like there used to be some type of medallion here which has fallen off. And the front of the speaker fires through this grill. Flipping it over, we see confirmation that this indeed uses a solid-state amplifier, as this transistor is mounted to the outside of this aluminum panel. There's a balance control which subtly attenuates the volume level of this speaker so that you can get it to play at about the same level as the main speaker. Note these hinges here. This panel actually lifts up. Let's pull back the retainer clip, which reveals a storage compartment for our cord. The jack with the smaller pin marked L provides the power to this outboard amp, and the jack with the larger pin provides the audio signal. Let's open this up now so we can repair the amplifier. Let's first remove these two Phillips head screws here. And now these two Phillips head screws. There's this rounded rectangular hole here, which I first thought was used for a cable, but I actually think it's used to place your finger inside to help remove this chassis from the speaker assembly. Okay, we have our speaker, audio transformer, volume potentiometer, amplifier, and filter capacitor. Reading this upside down, I can see that we have a 2000 microfarad at 16 volts, a 200 microfarad at 13 volts, a 100 microfarad at 6, and just the common position. So there are 3 capacitors in this tube. And it looks like we also have an electrolytic on the amplifier board. We'll test this electrolytic on the amplifier board to see if it needs replacement. And I'm just going to go ahead and replace this filter capacitor as it's obviously causing us some troubles. The first thing I want to do is disconnect the electronic chassis from the cabinet. So let's remove these terminals from the speaker. I'm just going to mark this one as being the black cable. Doesn't really make much difference, but I'd like to put it back together the way it came. Now I'll use some pliers to remove the terminals. The black. Now the yellow. Okay, let's see. Now note that the speaker is working fine, but there is a little rust here that we may opt to try to treat later on. Let's set this aside for now. I'd like to be able to remove this board so we can test and possibly replace this electrolytic, but they didn't seem to have future repairs in mind when they designed this thing. This board is attached with rivets and no screws are used. You can see the 2 rivets here, and on the other side, the 2 rivets here. Let me zoom up to give you a closer look. Now I'm starting to wonder if these 2 pieces are actually riveted on or just soldered on the other side. Let's heat this up with a soldering iron and see if we can't lift this board out. Yeah, that seems to work. Okay, yeah, that wasn't as bad as I thought. I thought these were rivets, but they weren't. They're actually little solder posts, as you can see here. Let's remove this electrolytic and give it a test. Just going to mark that this is the negative side. Okay, and it says we have a 45 microfarad at 10 volts. Let's first test it for ESR. So for a 45 microfarad at 10 volts, the ESR should be about 4 ohms. Let's make sure we're not over that. Well, we're coming in at a very low 0.52 ohms, suggesting that we don't have any troubles with ESR. And our 45 microfarad capacitor is measuring about 72 microfarad. That's a good bit over the 20% tolerance I would expect for this capacitor. So I think we might as well go ahead and replace this electrolytic. Let me see what I've got. I found this new capacitor to replace our old one here. The new one is rated for 50 microfarad at 50 volts, and the old one is rated for 45 microfarad at 10 volts. So the new capacitor is a little bit higher for capacitance and voltage, but that will be just fine. Let's quickly test the new capacitor to see how it compares to the old one. And you can see with the new capacitor, we also have a nice low ESR coming in at 0.16 ohms. But the capacitance at 51.69 microfarad is much closer to the rated 50 microfarads of the capacitor. And again, that's why I'm opting to use the new one. Let's go ahead and get it installed. Let's position the new capacitor so that we can read the voltage and capacitance rating. And as this is an electrolytic, we need to position the negative lead to the negative side of the board, which is this side here. And you can see on the capacitor the arrow points to the negative lead. I'm going to center the capacitor between the two holes and use my pliers to roughly bend the leads to the distance that we need to fit the board. One there and roughly another there. Let me flip this over and heat up the board so I can slide this lead in. There we go. Almost there. Let's flip this around now and solder the capacitor to the foil side of the board. Let's position this upright so you can see that a little bit better. I'm going to turn on my fume extractor now so you'll hear that in the background. And yeah, I know this is a huge tip I have on the soldering iron now. Way more than I needed to solder that tiny electrolytic. But I didn't feel like removing it as I'm going to need it again to solder these large lugs here. Let me just melt that down and show you. Okay, I'm just going to trim these leads. And while I'm in here, I think I'm going to cut down some of these sequoias here. You can see that they left these leads of these components awfully long on this board. Let's trim these down a little bit, as that can't hurt to make this board just a little bit quieter. And I'm also going to clean up some of this flux that was left on here. To make it a little bit easier to reattach this board to these solder lugs, I'm going to use my desoldering iron to remove the old solder from both these lugs and the board. Let's do that now. Now I'm going to drop the board in position and heat up these lugs as I do that, just to loosen up that solder a little bit. Okay, that appears to be in position. Let's add some solder to these lugs. Okay, looking good. Let's turn our attention now to this multi-section capacitor. These are the replacement capacitors I've gathered. To replace the 2000 microfarad 16 volt section, I'm going to use two of these 1000 microfarad 16 volt capacitors wired in parallel. To replace the 200 microfarad 13 volt section, I'm going to use this 220 microfarad 25 volt capacitor. And to replace the 100 microfarad 6 volt section, I'm going to use this 100 microfarad 25 volt electrolytic capacitor. To install these capacitors, I'll need to mount a terminal strip to this aluminum plate and cut the wires to the old capacitor, and do that in a way that we can hopefully reuse these color-coded wires. Let's see what I can come up with. I've sketched out a plan for our electrolytics terminal strip. I'm going to use an 8-terminal strip and use the 6 terminals in the middle to connect our electrolytics. The 2 outer terminals have feet with screw holes, and we'll use those to attach the terminal strip to the chassis. Here's a look at the terminal strip we'll use. Now, this outboard amp does not use the chassis for ground, so we want to make sure that we don't use the 2 outer terminals to connect any of our capacitors. On terminals 1 and 2, I'll have the 2 1000 microfarad capacitors installed in parallel. The 220 will connect between 3 and 4, and the 100 will connect between 5 and 6. I'll orient the 1000s with the negative pointing this way, and the 220 with the negative pointing this way. and I'll place a jumper between 2 and 3 to connect the negatives. I'll orient the 100 microfarad with the negative pointing this way, and connect a jumper between 5 and 3 to connect to the negatives. And on terminal 3, I'll also connect the black wire. The red wire will connect to terminal 1, the green wire to terminal 4, and the blue wire to terminal 6. Let's begin. I'd like to use these existing holes to mount our terminal strip without having to drill any new ones. Now, if I line the terminal strip vertically like this, you can see that the screw holes don't quite line up with the holes in the chassis. However, I noticed that if I mount the terminal strip sort of diagonally like this, it seems as though we'll be able to use the existing holes. Let me get some hardware and mount the terminal strip in position and see if it works out. Okay, I think that'll work nicely. Let's go ahead and get our wires and capacitors hooked up. Here's our completed terminal strip with the capacitors installed. Let me just put the old capacitor in position real quick to show you the difference. So these 4 capacitors now replace the 3 capacitors that were in this old tube. Let's remove that, and I'll put that aside. And note that I'll keep the old clip attached. It's not getting in the way, and I'd like to keep this old tape player as original as possible. Note that I've used a wire tie to tame this input wire a little bit, attaching it to this unused terminal of our terminal strip, and I've also used a wire tie to bundle our color-coded wires as well. Before we put this back together, I'd like to do one more thing, and that's to spray a little control cleaner in our potentiometer here. I'm going to use the neutral control cleaner for this. A couple squirts in there. And work the knob back and forth. Okay, that should do the trick. Let's put this together and try it out. Whoops! Something went very, very wrong. Do you know what it is? Let me know in the comments. And learn more in part 4. Stay tuned. To stay updated, please subscribe to my channel and click the bell to receive notifications when I release new videos. And if you like this video, please give it a thumbs up. I'll see you soon.